Good day, my wonderful viewers out there. Today on mathematics, we shall be looking at modular arithmetic, and under it we have a subtopic which is cyclic events of modular arithmetic. And I want us to understand that a good example of a cyclic event is our work log, and the work log has its arrangement pattern from 1 to 12. While in the case of the example that we have here, it has its arrangement pattern in form of a work log from 0 to 5. So we are going to see how we can use this example to find the corresponding pattern of A, 5 plus 8, and B, 7 plus 8. So in this case, we say solution. We say solution. Now, in order for us to solve through it, there is need for us to understand or to know the mode in which this figure is operating on. And for us to know the mode in which this figure is operating on, we count from this 0 to 5, because we need to understand that modular arithmetic is all about counting the reoccurrence of numbers, either by numbering them or by the use of letters, that you can achieve by addition, subtraction, and then multiplication. So in this case now, in order for us to know the exact pattern in which this figure is operating on, we tend to count here using number figure of numbering by saying here 1 from 0, you say 1, 2, 3, 4, 5, and 6. So the counting from 0 to 5 gives us a total of 6. So we say therefore, the mode of the figure is 6. That is, i.e., the figure is in mode 6. So the arrangement pattern of this figure here, of this cyclic figure, is in mode 6. That is to say, whatever it is that we are solving in this A and B must correspond with a pattern in this figure in such a way that whatever we'll have as our answer will not exceed any of the numbers in this figure. So in doing that, we take the A part of it. We say for the A, which is 5 plus 8, equal nothing. Now at this point in time, if we say 5 plus 8, just with our normal arithmetic, our normal addition and then subtraction. Now at first, let us use the case of this addition here. When we say 5 plus 8, what do we have? 5 plus 8 will give us 13 based on our normal arithmetic. Now this 13 should be in mode 6, in obedience to what we have here in the cyclic figure. Now if we look at it now, we will see that this 13 is not corresponding to the figure that we have in this cyclic figure. So therefore, there is need for us to reduce this 13 in such a way that it will not exceed 6, which is the mode pattern of this figure. So what do? We say i.e., the 13 divided by 6. 13 divided by 6 will give us 2 to remain 1. We say therefore 5 plus 8 will now be equals to 1 in mode 6. We consider the remainder. So the remainder is the number pattern that corresponds with the cyclic event. That is why we have it as 1 mode 6. So when you say 5 plus 8, is the same thing as 1 here in this cyclic figure. We also have the case of the B. The case of the B is 7 plus 8 is equals to, now under normal arithmetic, 7 plus 8 will give us 15. So we'll have 15 here in mode 6. Now this 15 is more than 6. What do? We reduce it in such a way that it will have a remainder that is not more than 6. So we'll say i.e., 15 divided by 6 will be equals to, so 15 divided by 6 will give us 2 to remain 3. So we'll say therefore 7 plus 8 is equals to 3 in mode 6. So the corresponding pattern of 7 plus 8 is 3. And if you watch here in the figure here, we have 3. So with what we have done here now, we will be able to solve this given activity, where we have it that the certain pattern of this figure here is from 0 to 4. Now you have to use this figure to find the corresponding pattern of the following, where we have A, 8 plus 9, B, 6 plus 13, and C, 4 plus 15. Thank you very much for tuning to this channel, and God bless you.